Hey everyone, my name is Don Rivera Diaz, and today I'm walking you through my IT Capstone project. The big question I was trying to answer is, can Python machine learning system actually compete with the commercial security tools that many enterprises spend hundreds, a lot of money on, thousands? More importantly, what does that mean for mid-sized organizations that don't have that kind of budget? Now, as a teacher turned tech, I have worked with districts and agencies, organizations that are small, medium, huge. So I have a lot of passion and interest in this topic. Let's get into it. Here's the problem that I personally keep running into. So when I started this research, I noted my expertise being mid-sized companies. We're talking 100 to 1,000 employees. They're getting hit with the same attack as big enterprises. Problem right off the bat? Well, not as many resources, not as many defenses. 43% is the breach rate. That's almost 50%, almost halfway. 2.9 million and increasing dollars is the average cost per incident. The tools built to stop those attacks, hefty. More than the first house I ever bought. $50K all the way up to $200,000 a year. And that's just for licensing. It's not realistic. It's not practical for many mid-tier organizations. Even if they could afford it, untuned SIEM systems may throw false positives at a 20 to 90% rate. That's a huge fluctuation. So it leaves you feeling uncertain, not as confident, maybe really pushing you to burnout. So say you have a small security team of 2, 3 people, a couple to a few. They're buried in noise, buried in real threats, and more incidences keep slipping through. That gap is exactly what I wanted to study. There's a problem. Let's find the solution. So I built this study around 3 questions. First, do the detection numbers actually back up what vendors are claiming? Like, how does Python or ML machine learning really stack up against commercial SIEM in accuracy, precision, recall? Second, what does it actually cost? Not just the sticker price, not just the raw data, but operationally. Staffing, time, infrastructure, etc. Third, what are the real barriers to each approach? And what can a smaller organization actually do about them? Those 3 questions drove everything you're about to see. Here's how I set it up. On the Python slide, I built a random forest classifier using SCIKIT learn. So, SCIKIT learn. I ran it on the CICIDS 2017 Friday DDoS dataset. That's over 225K, 225,745 to be exact. That's the real network flow records. That's what we indicate. Now, we reached a 80-20 train test split. No hyperparameter tuning. I didn't want to optimize it to death and then claim it performs great. I wanted to see what a realistic baseline deployment actually looks like. So I'm very practical. And on the SIEM side, I didn't have access to enterprise platforms directly. I used those sources that I had access to. So I went through published vendor benchmarks. What else? Industry reports, organizations like NISC, Search Inform, what's that? Drop Zone AI, Real data, real sources. Now let me show you what came out of it. So this is my actual terminal output. This isn't a demo environment. This isn't staged. I ran this model on over 225K, so remember that number, 200,025,745 network records, and got virtually 100%, virtually. I know it's a long way there, but 99.99% accuracy, precision, recall, and F1 score. 5 total misclassifications. That's out of nearly 250,000 records. I want to be really clear. This is a default SIEM learn. So scikit learn. Random forests. It's not fancy tuning, no custom architecture, just a model running on a standard public data set. You can do it, I can do it. And it was difficult, but accessible. I was honestly very surprised when I saw this. So let me break down exactly what those numbers mean. The confusion matrix, 19,536, so over 19K, benign records. Correctly classified 25,602 attack records, over 25K, correctly. Those were correctly classified. And those 5 misclassifications, well, 2 benign records got flagged as attacks, false positives. 3 actual attacks got through, false negatives. That's it. 5 out of 200,025,745. So over 225K. When I talk about near perfection detection, this is what I mean. These aren't projections or vendor claims. This is the model running on real data. This one's my favorite slide to talk about. The most I had a lot of just fun tuning. And as I worked on this, I spent a lot more time on this slide, particularly just looking at it and studying it and making sure everything was accurate. So this data set had 78 features, 78 different characteristics of network traffic, and the random forest on its own figured out which 15 of those actually matter for catching attacks. The top one, average forward segment size, basically captures how DDoS flood packets and how it's sized differently from normal traffic. The model found that by itself, no human had to write a rule for it. With a traditional SIEM, an analyst has to manually, so by hand, define detection logic for every single one of these. The ML model just figures it out. That's the fundamental difference. And for me, the elephant in the room. Now let's look at how that compares to commercial SIEM across the board. Accuracy, well, Python and ML, machine learning, is nearly 15 points higher. Precision is almost 28 points higher. Recall is 12 points. F1 over 20 points. The reason comes back to what I just said. Machine learning is finding patterns in the data directly, including attack variants that nobody has written a rule for yet. A SIEM can only catch what it's been told to look for. Machine learning adapts. This slide matters a lot for smaller teams. So I want to slow it down here. Python machine learning optimized 1.5% false positive rate. A tuned commercial SIEM, 15%. Untuned, 35%. Financial sector, 70%. Drop zone. AI found that 90% of security operation centers are dealing with serious alert backlogs because of false positives. Think about what that means in practice. If you've got 2 or 3 analysts and 35% of your alerts are noise, real attacks are getting buried. Your team gets burnt out, chasing ghosts, and the actual threat slips through. False positive rate isn't just a number, it's an operational reality. All right, so money. Year one, Python machine learning runs you about 30K, right? 30,000 to 60K, 60,000. Zero licensing costs. Modest hardware development time. Commercial SIEM, though, 120K, 120,000 to 290K. And that's being conservative. The licensing alone can hit 200K a year. So we're talking 70% to 80%, right? Give or take a few percentages. Cost reduction with the machine learning approach. Now, the big caveat, that math only works if you already have Python and machine learning expertise in-house. If you have to hire for it, then the gap closes fast. So about being efficient. That's not a deal breaker, but it's just something worth considering, and you just have to be honest with yourself. So given everything I showed you, how does an organization actually decide? I built this framework to make that concrete. It starts with one question. Do you have Python and machine learning experience on your team right now? If not, get on it. If yes, you're willing to put in the upfront development time. Python and machine learning is your move. Better accuracy, massive cost savings, full control. If no, you have to budget cover 120K about, right? Commercial SIM makes sense. Faster to deploy, vendor support, compliance ready out of the box. If the answer to both of these is no, well, hybrid. Use machine learning to cover your highest value assets. Use a lightweight SIM for compliance visibility. You get the best of both without overcommitting to either. We made it. So here's where we landed. Python machine learning hit 99% accuracy. Commercial SIM benchmarks at 80% to 90%. False positive rate of 1.5% versus 20% to 90%, and 70% to 80% cost savings in 1 year. Those numbers are significant. Honest conclusion of this research isn't Python machine learning wins. It's that neither approach is right for every organization. The right answer depends on your team's expertise, your budget, and your operational reality. That's what framework gives you, a way to make that call based on your actual situation, not a marketing technique, not marketing materials. So if you have any questions, feel free to reach out to me. I am Don Rivera Diaz, and I had a pleasure working on this. I learned a lot. Thank you so much.